Solve 3 tangent squared x minus 4 equals negative 3. Okay, now they didn't put a parenthesis on here. I want to assume that the parenthesis should be right there. Now if I want to solve, again, I'm trying to isolate. So the first thing I'm going to do is, let's get rid of this negative 4 over here. And so I add 4 to both sides. That goes away, and so I have 3 tangent squared x equals 1. Now I'll divide by 3. And so we have that tangent squared x equals 1/3. Now, when you have tangent squared, we can do a few things. That would be a Pythagorean identity, but that's not what I'm going to do. I'm going to take the square root. Now, whenever we take a square root that's not originally there, we need to add to a plus or minus. So, technically speaking, this would be positive or negative 1/3. So, we're left with tangent of x equals plus or minus the square root of 1/3. I'm going to divide it like this. Now, it's not the way we usually leave it in this form. Typically, we would multiply by the denominator a square root of negative 3. I'm going to do it over here like this. And typically, we would see this value as square root of 1 times square root of 3. When I multiply these, I would have a square root of 3 over here plus, and then square root of 3 times square root of 3 is square root of 9, but the square root of 9 reduces and becomes square root of 3 over 3. Now, I'm not going to actually leave it this way, though. This is technically the better way of writing it, because why not? How do you get rid of a tangent? You would take what's called an inverse tangent. So I would take this, and I would say, let's take the inverse tangent, because what that does is these two would simplify away, and I'm left with x equals plus or minus, and you would take the inverse tangent of this. But I think it's going to be easier. Let me do plus or minus here. The square root of, I'm going to do it these values because I can use the hand trick on this one. So remember, psi y cos x tangent is y over x. So if you flip your hand over, I'm looking, this is one y finger, 3 x fingers. Y is from the top, x is from the bottom. This is bending my ring finger because I'm looking at the back of my hand since it's inverse. I'm bending my ring finger. I have 1 open on top, 3 in the bottom. And when I flip my hand over, that means x is located at plus or minus 30 degrees. Now here's the deal. When you think about tangent at 30 degrees, this is kind of like the previous problem. There's positive 30 degrees, there's negative 30 degrees. That one's a little too close to 40. Let's curve that down. Tangent is positive here because everything's positive here. That's positive 30 degrees. This one's negative 30 degrees, which we could say or plus or minus pi over 6. Now, tangent's positive, it's negative here. Well, it's also positive here and negative here. So, what are these values? If this is pi over 6, this one over here would be called, it's almost 1 whole pi, because that's what that is right there. That's 1 whole pi. This would be 5 pi over 6. And this value would also be true, because tangent would need to be positive and positive. So we'd also have this one, which is 7 pi over 6. So truthfully, you have this one. You have every single pi over 6 answer. So this one, and then you would add a pi. This one, and then you would add a pi. And you could start with a negative because it's quicker. So the actual answer, the way they would write it out, would be that x can equal the first answer, which is pi over 6. And then if you add a whole pi, so this time instead of saying plus 2n pi, you would just say plus n pi. The second answer we got was down here. This is negative pi over 6. Negative pi over 6 plus n pi when n is integer. It's got to be a whole pi that you're adding and subtracting. And that would be our answer right there. Now I got one for you to try.